Hello, welcome back to another episode of 0 to 60. I'm here with the freshly installed single turbo. The point in this video is hopefully we're all going to learn I'm going to learn something about a solid state relay, but the reason this has come about is I've got a bit of a problem. So hopefully you've all seen yesterday's video, which I'll put a link to, or I'll forget to put a link to up in the corner, where I was doing some pulls with this thing. It sounds wild, but we've got a fuel pressure issue. So basically, when we get to the top of the RPM, so about 6750 onwards, I start to lose low pressure fuel pressure and I'm dipping down to low 60s, and I'm also getting a rail pressure drop even when I'm upping the port injection. So I think this is all stemming from a low pressure fuel pressure issue. Now the low pressure system that I have in this car is just two Warbro 460s. One is connected to the factory EKPM, the factory fuel pump module, and the other is connected completely independently. I was controlling it by the BMS port injection controller, and I'm now controlling it by the Reflex. Now the Reflex gives you the option of a PWM control, so you can actually have the pump on a progressive system. So it's not just on or off like it was with the previous system. And to me, it makes sense that you have that option because you don't need full 100% fuel pressure straight away. You do need to feed it in as the power comes in, although I am starting to realize that with a single turbo, that's over a very, very short time period. But mine is wired in with a solid state relay currently. And I'm wondering if this is why I'm having the issues with my low pressure system. Maybe the solid state relay is not wired in correctly. Now, before I show you my lovely or not so lovely wiring job, I just want to explain. So I've never played with solid state relays before, but reading about them quickly, it made sense. They're basically a relay that, instead of using a mechanical switch, is using MOSFETs to do the switching, which means it can do it very, very quickly. This style or old school relay, you hear them click because they literally have a magnet inside and two terminals. The magnet pulls the terminals together and they click and they're on. You turn them off, the magnet lets go, it springs back, and then you get a break in the connection. Nice and simple. With the MOSFETs, it's basically an electronic switch that's doing that switching for you. But because it's electronic, it can do it very, very quickly. Where I all sort of went a bit pear-shaped was I sort of forgot to order my solid state relay when I was doing all the ordering. And the day that I had to get it installed, and because we were moving, I had to just find something locally. Now, the only one I could find locally is this little solid state relay here. Anyone that's bought the Haltech switch, the Haltech SSR, probably notices that it's the same one. So when I realized that this is the same unit that Haltech sell, I got it from JCar. I thought, yep, let's just get it. I would have bought it from Haltech if I could have got it in a reasonable time, but it would have been a few days from Haltech. It's not much cheaper from JCar. I've gone off track here. What was I talking about? Yes. So no worries, install it just how Haltech install it. Now, again, I didn't realize how to install it until I went and picked it up, and then I started researching how to wire them in. Haltech wire them in a few different ways, and then the internet got in my head, and there's so many different ways that people recommend wiring these up. Some use them as earth switching, some positively switch them or switch the load. Some people use resistors, some people don't use resistors, some people use diodes, some people don't use diodes. Now, Haltech said you must use a resistor, or they tell everyone that you must use a resistor, but then as I delve deeper in it, the resistor is only needed for some model of Haltechs, and it's to do with the way that they run an output on the digital outputs, because a digital output, whether it's the Haltech or this Reflex or whatever you're connecting them to, they are basically an on and off switch, and the on and off signals are just a different voltage. So this isn't right, but say 2 volts is on, 0.5 volts is off, and it switches between those two outputs. Now, I think Haltech used the resistors because some of... Sorry, I thought a fuel pump was running. Some of their older or some of their specific ECUs, that switching point might be at a higher value. Now, these actually in the specifications say that they switch on anything above 3 volts. You can actually see... I don't know if the GoPro is going to pick it up. There we go. So you can see at the bottom, it says 4 to 32 volt DC input for the switching. In the actual specifications, it says anything over 3 volts will switch it. So if you apply 3 volts to these terminals, it then joins these terminals over here. It's that simple. But I think what the issue is, some of the Haltechs might be putting out close to the float voltage of this switch. So if you don't use the resistor on a Haltech ECU install, it might falsely pulse the solid state relay, or it might think it's on anyway. That's my understanding of why those resistors are there after a few hours of reading and talking to a few different people. Please correct me if I'm wrong, because I'm trying to learn, I'm trying to learn together. So if that's not right, that's not why the resistors there, let me know. There's quite a few helpful threads on the Link ECU forum and also on the LS1 boards, and it seems that that resistor thing is pretty much only to do with Haltex, but correct me if I'm wrong. This one is directly wired into the reflex, and I have no resistor on the input side, and it seems to switch on and off correctly. It's not firing right now, put it that way. So the second thing that Haltech mentioned is a diode. Now, the diode, I think, is where my problem is. It seems to be a bit more of an important piece to the puzzle than the resistor. And what the diode does, it's to do with the inductive load that the fuel pump is. And I think it's just to do with loopback, or, like, I don't know. It's got something to do with voltage not going where it needs to go in the motor, in the pump, and escaping straight out the switch. Now, these diodes are something that you're supposed to use on original style relays, and it's something to do with protecting the contacts inside the relay. Some traditional relays will have them built in, some solid state relays have them built in, and I kind of just assumed that this one might have it built in. We'll use it and we'll see how we go. But the fact that I'm losing, or I don't have enough fuel pressure up the top, is concerning me. And two 460s should be more than enough for the amount of power that we're putting through this thing at the moment. Which is, I reckon, it's probably best part of 700 horsepower. Probably 700 wheel horsepower, getting close to anyway. But I shouldn't be running out of fuel yet. Well, I don't think so. Anyway, what I want to do in this video, I want to actually do some tests, see the actual voltage that we can measure on the output side, or see the voltage that the pump is getting. And if it's not that full 13 volts, then the relay wiring might be the problem. I am very sorry it took me too long to explain that, but hopefully you've watched all the way through and you understand what we're doing here. So let me explain how I've got this one wired in. Actually, if I put the light here, you can see it a bit better. So this is the original relay that I was using, and it was controlled by the BMS port injection controller, and it is just a switch. It turns the power on, and it gives a full direct connection between the fuel pump and the battery. And I'm still currently using that to switch this on, so that this doesn't have constant power all the time. Basically, ignore the old school relay. It is literally just a switch to turn this on, because I do have a nice battery source right here. But what do we got? So this wire here is coming from the reflex, and it is, you'll notice, it is on the negative side. We have positive coming in here. Now, I know that wire looks quite thin, but it's quite a short wire. I think that's actually 15 or 20 amp wire, so it should do the job. But we've got a constant power coming into this side. This wire here goes to the fuel pump. So the fuel pump is always connected to positive on the battery when this relay is on. Just keep a note of that. This is the negative side of the fuel pump, and this is the switched side of the fuel pump. So this is the input side, and that's the side you put the load on, and it's the side that switches, and this here is just a direct connection to earth. So this is earth on the car, that is the negative side of the fuel pump, this is the positive side of the fuel pump, and again, the fuel pump's always got power, so as soon as this side bridges and makes a connection, we are good to go, and the fuel pump should turn on, should work. So, for me to measure the power the fuel pump gets, I need to clip my positive, oh, it's getting slippy, my positive lead on here, my negative lead on here, I think, and that should be good to test. So let me turn the voltmeter on. Okay, you can see there, it's currently reading 0.4 volts. And let me show you what I'm going to do. Now, the Reflex has this handy feature called bench test, which I had plugged in. Let me see if my laptop's going to work. The car ignition is on. I have a 100 amp power supply, courtesy of my brother-in-law, who's letting me stay at his house, by the way. So I'm going to turn that on, and that will keep the car at 13.5 volts. So even though the alternator's not running, the car's getting 13.5 volts. So that's what we have to play with. Now let's fire up this bench test, and we'll scroll down to the fuel pressure down the bottom. So fuel pressure is currently at 70 psi, and we should be good. So let's run a bench test, and we'll just see if that fuel pressure changes from 70 psi. It doesn't. The rail maintained 70 psi. Now this is a deadhead system, so it really shouldn't lose fuel pressure unless we start the engine, which I'm not going to do, so we'll leave it at 70 psi. It does mean that this fuel pump is fighting, well, it's not fighting anything, it still goes through the factory regulator, so that should be fine. So the next thing we need to test, we need to run that bench test and see how many volts the fuel pump is getting. Now it should get full battery current because I'm running the bench test at 100% duty cycle. Yeah, it is 100% duty cycle still set. Okay, so let's see what voltage we get. Now I'm gonna try and get you guys near. In fact, you can just watch there. All right, you guys can see the voltage there, so I'll run the fuel pump and we'll see what it gets. It's 11.2. So, interesting. Interesting. Okay, I'm going to turn the car off. 11.2 is not enough. That wall row needs to see 12.5, 13.5 volts really. So there is an issue. So I think I'm going to work out what diode to use and try and install the diode, and we'll see if that changes what the fuel pump sees. Okay, so diodes. Everyone seems to use these 1N4004s. They're rated at 400 volts and 1 amp. Now keep in mind, we're just trying to sort out like current leakage or something like that, so it doesn't need to do much, but people seem to use these on everything, and it is the ones that I've seen in the Haltech install diagrams. I have it installed here. Now the reason I've just put it here is just for testing. It looks dangerous, and it probably is, but it is what it is. But for testing it should be fine. Now the diodes are normally inside the relays, so the fact that it's at this point here instead of at the fuel pump shouldn't make any difference. But let's see if it works. Okay, so turn the meter back on. Hopefully you can see that. And we should have the reflex here. Bench test, send bench test, send. It's 11.2. So I don't think that's it. It's the same. I might just see what voltage we are getting here in case we've got some losses through cables. So if I put that onto that side, that should earth. Okay, so we have 13.3 volts at the relay, but we're losing over 1.5 volts in the relay, or is it the PWM? You know what? Even though I thought we didn't need the resistor, I might see if I can get one of those 1.2 kilo ohm resistors and wire in. So much fun. All right, see you guys in a sec. All right, so I now have a 1 kilo ohm resistor on the input side. Clutching at straws here. Don't really know what's going on. But we should be able to just send bench test. 11.2. So we're not getting... So we've got the resistor, the diode, and nothing has changed. The fuel pump's just not getting enough voltage. I'll do some research. So before I checked voltage across the relay, so we've got positive coming in here and then earth going out there. When I measure there, we're at 13 volts. However, if I run the test, it drops 11.1. So, the relay is doing what it's supposed to be doing, but I'm losing some current through the wires. Basically, the pump is putting too much load on it, and the pump's not getting enough current. Right. I can't exactly remember what I last filmed. However, I've come to the conclusion that the pump's dying. So, the point of this video was to learn about solid-state relays. The resistor and the diode didn't seem to affect anything that this one did. That doesn't mean that they shouldn't be there. If anybody knows what the hell is going on with them or how they work, let me know. But yeah, I've checked voltage at all the different points, and I actually don't think we're losing current through the wires. There was a couple of dicky connections on those crimp terminals that I probably should have redone earlier. But yeah, measuring voltage whether I measure it at the breakout point on the stereo, which is like a 4 gauge to the battery, or if I measure it at the fuel pump, it is dropping. So I think the fuel pump's just drawing a hell of a lot of amps, and I've opened up the inspection thing and we've checked it there. I'll play a little clip here. Let me know if you think it sounds like it's dying. Because my main fuel pump, I cannot make noise. Well, it makes a little bit of a hum when you cycle the ignition, but yeah, the main fuel pump is pretty quiet compared to that one. I mean, I don't know for sure how hard the main fuel pump is being driven at key on, so it might only be getting a small amount of duty cycle. Playing with the reflex duty cycle, and I've tried it at 50, 75, and 100% duty cycle, it starts squealing at 75% duty cycle, the secondary pump, and it just doesn't. It sounds like it's dry, but there's obviously fuel in the tank. I've also tried different hertz frequencies on the reflex, everything from 20 hertz up to 200 hertz, and it makes no difference. The pump doesn't sound good. Now, normally I'll just throw another pump in. One of these pumps is Chinese, and the other one is a genuine Walbro. I think I use the genuine Walbro for the main pump. And I chuck the cheap Chinese ones in. They've been fine. This will be the second Chinese pump that we've had a failure with. And we've used quite a few of them. So no complaints, but I think I'm just going to chuck another pump in. However, normally I'd just throw that pump in because it'll be in the corner over there. I think it's in storage. It might be at Dylan's house. It's going to take me a day or so to get that fuel pump, just to find the bloody thing. So I'm going to leave this video off here. I didn't want to just not put out a video today. I want to get the video out. But yeah, not very helpful. I do apologise, guys. But let me know if anybody watching this knows how these solid-state relays work. Let me know if you think the fuel pump's dying and how I can fix it tomorrow. Because that'll be when I get my hands on my spare pump anyway. I also might redo the wiring again. We'll see. I also want to go to Queensland Raceway Open Day on the weekend in this. So we're going to get something working. Anyway, guys, thank you very much for watching. I'll catch you on the next one.